All right. Hi, guys. Glad to see you here. We have three people other than me and myself, so that's good news. I just sent out an email as a reminder, so hopefully we get a few more. Yeah. Okay. So the plan for today is that we'll basically go over anything you guys want to go over. It's more of like a Q&A type of thing, but if no one has any questions whatsoever, I can just go over some concepts you guys want. But yeah, hit me. Do you guys have any questions that you want to go over, like some general concepts or some specific things that you guys are uncomfortable with, you think other people might be struggling with too?
So my main concern is really like my time management skills suck. Like I literally don't know how, but every time I complete like four problems, I literally look up and it's 15 minutes left. And I'm just like, how in the world am I supposed to finish the rest of this and show all of the work in 15 minutes? But I don't know how I do this, but my time management sucks. So yeah.
Gotcha, gotcha. Okay. So yeah, this is definitely a common concern. So thank you for bringing it up. Obviously, there's not like a whole lot I can tell you other than be quicker, but let's see what we can do. So if we break it down, we have 70 minutes to basically download the exam, print it out, do it, show all your work, turn it back in, and get out of there in exactly 70 minutes. Okay. And so what what we're thinking is that you'll take 5 minutes to print it or just to download it, get it onto your iPad, whatever. Um, 50 minutes to do the exam, which I know it doesn't feel like a lot, but apparently in previous semesters, um, like the moment they start in the lecture hall, it's exactly 50 minutes and then you stop after 50 minutes. So that's kind of the mentality they're giving you 50 minutes to do the exam, just like they did in previous semesters, and then 20 minutes to like print and then re upload. So that's the idea for that. And then another 15 minutes to upload. All right. So here's a little hint. If you're, if you've been uploading properly all semester, it shouldn't really take you 15 minutes to upload. So print it or get your notebook out, whatever, as fast as you can. Try to save a couple minutes in this 5 minutes. So maybe it'll only take you 2 minutes, right? So you've saved 3 minutes. And then you have all of your 50 minutes. And then, we're going to tell you to stop working at the 55-minute mark, right? So right here, we're going to tell you to stop and upload. You should do that. You should stop and upload it. But if you are still not done, go back to your work and try to finish your exam and re-upload it, because you can upload to Gradescope as many times as you want, and we're only going to look at the last submission. Like, we only have access to the last submission. So once we tell you to stop, you should stop and upload, but go back to your exam, take an extra 5-10 minutes, like quickly scribble in some other stuff or whatever you left blank, and then re-upload, or check your work or add stuff, add some work. Just like you have a little bit of time. If it only takes you a few minutes to upload, you have a little time to go back and try to re-upload. That's the mentality we have. Of course, I'm probably not supposed to recommend this, but if you want to take an extra 5 minutes into your uploading time and finish the problem you're working on and then upload, you can do it. Like I said, I don't recommend it, because if you are unable to upload, that could result in a point deduction. But basically, my whole spiel is that even though you're only supposed to have about 50 minutes for the exam, if you play your cards right, you're gonna have 55 to 60, which isn't too bad considering previous students in the class had 50 exactly. Like, they sit in the lecture hall, they start, and they have exactly 50 minutes, and then they have to stop working. So it's a little bit more flexible with this, which is a good thing. Bad thing is that you have to be kind of tech savvy. Otherwise, you actually have less than 50 minutes, if it's taking you more than 20 minutes to do all the tech stuff, which hopefully it shouldn't. Use the scanner app to upload if you are not like using like an iPad or something, or some sort of writing tool. Use the scanner app, because any other method will take you twice as long. Okay. I was recommending that people take pictures and then put it into Google Docs and like save as a PDF. Don't do that. I started using the scanner app and I was like, oh my gosh, this is so much easier. Okay. So if you don't have it, I think the one I use is called Scannable, but there's like a dozen different free apps. So download it, practice with it if you don't already have it, and try to get your upload time to a minimum. In terms of taking the exam quicker, the biggest thing is just to be prepared, right? So the more prepared you are, the quicker it'll be. If you've seen that exact problem or very similar problem, that's gonna help you do the problem faster, right? So do all the web work, go through the course notes, and just like rework all the problems that you're even a little unsure about. The practice exams that she emailed out, you should definitely do both of those. She emailed 2 of them. 6 p.m. she's going to go over one of them. But yeah, do both of them. Compare your answers to the answer key. Make sure everything's right. You know how to do everything, and you should know how to do it quickly. All right, and then the last tip I have probably is a formula sheet of some kind. And we can kind of talk about like what I personally would recommend you put on the sheet, but really it depends person to person. If I were taking this class, which right now is open notes, which is great because it never has been open notes before, you should make like a sheet that it's like a cheat sheet basically, because it's open notes. Why not, right? But the problem is, this is my guess that a lot of people are using all of their notes, and so they get stuck in a problem and they take 10 minutes to like look it up and stuff, which is fine if you weren't under a time crunch. So the formula sheet, you should write down only the stuff that you truly like will not remember. All of that you should write down on your formula sheet, and it should only be like one sheet, maybe two, like front and back, because if you're flipping through, it's going to take you forever, right? So a quick sheet that just has like, say the quadratic equation on it, the rules for like the polynomials and stuff, like what degree is what, and if it's negative, which way it faces, all that fun stuff. That should probably be on your formula sheet if you don't have it memorized, which I suspect not a lot of people do because it's kind of a lot to memorize, right? So formula sheet, be prepared. Scanner app, don't take too long to upload. Those are probably my biggest tips. But yeah, just be prepared. Does that help? Maybe a little.
Yeah, it helped a lot. But I have a question about the scannable thing because I use scannable and it makes me like go to my Gmail and my Gmail takes forever to load. So it will make me go there to download it too. So do you have like another scan app that will actually let me go to Gradescope quicker than that?
The way I do it to upload my own assignments for my other classes is that I'll scan it and then I'll upload it to my Google Drive, not my MSU Drive, just like my Gmail, and then go on your laptop to Gmail, take it from your drive, download it, and submit it to Gradescope. And it really only takes me a
Okay.
minute or two. So yeah.
Okay, thank you.
So definitely.
What I do, if you're curious, I use an app called Adobe Scan. It's like the same kind of concept, and I just like take picture, just change it to PDF, and I actually share it to my MSU account, and I kind of just save it to my computer itself, like into my files. So then when I go to Grayscope and upload, I just go for my files and then find like the name of the PDF and then upload it through there. If you want to use your MSU account, I guess.
Yeah, I also use Scannable, and if it's your Gmail that you said takes forever, I send mine right to my Outlook, and I can download it right from there, like also into my files. And then when I go to Gradescope, I just upload it right from my files, if that helps. Thank you.
Okay, awesome. I love the input. Thank you guys. Yeah, so I do it with Drive, but there are like a dozen different ways to do it. Just find a good, quick way and get good at it. Don't take the whole 15 minutes to upload. You really don't need 15 minutes. You can, I don't know, some of you may have joined late, but basically I was saying that you should upload it when we tell you to upload at the 55-minute mark, but then you can go back and change and add stuff and re-upload. We're only going to look at your last submission. Okay, so if you're good at it, you don't have to spend an entire 15 minutes uploading. You can spend some of that time on the exam if you're struggling with timing. All right, do we have any other questions you guys want to go over? Any concepts, any concerns you think a lot of people are struggling with? I can go over it.
I actually have a question. So for like the end behavior stuff, I like understand the chart and I understand how like if the degree is negative, like how it all works out. I just don't understand like in our notes she would transfer it into like this different thing where it'd be like as x is negative infinity, y is positive infinity, and then as x is positive infinity, y like I don't understand how it like translates into that formula or like not formula but like way of writing it as in just like doing the end behavior.
Yeah, I got you. Okay. So I'm glad you asked that question because it sounds like you have the hard stuff figured out, which I honestly haven't reviewed that much this semester. So yeah, you're thinking like as y goes to infinity, what does x go to? Is that the kind of thing?
Yeah, it's like it's end behavior and then that's how she was writing her answers for like the end
Yeah,
behavior.
sure.
So yeah.
Yeah, okay. So let's take an example graph. And I'm just gonna make some squigglies. And so that'll be like our first example graph. And let's make another one. All right, so we have two different types of graphs. The middle stuff, it can be as many bumps as you want, whatever. We're just looking at that end behavior. So those arrows is what we're focusing on. When we're looking at when y approaches infinity, and then also when y approaches negative infinity, we're kind of thinking of like when we're traveling along the y-axis, which way is our graph going to go? So, for example, if we take this first graph, as we travel to the negative part of y, right? So we're going to negative infinity on the y-axis. Which way is x going? Well, we got to look at our graph. And so it's going down and it's going to the left. And so I kind of made these going down, but if you see like since it's curving this way, it's also going to the left. And we know that the left is negative for x and the right is positive. So as our y is going down, our x is going left, therefore our x is going negative while y is going negative. So we know for this one, as y approaches negative infinity, x approaches negative infinity. And then if we see positive infinity, all right, well, let's check out when y is going positive, which means when y is going up, x is going to the right, right? It's going this way. And so as y goes to positive infinity, x also goes to positive infinity because it's moving right. So we know that x approaches positive infinity. All right, and then if we look at our second sample graph, when y approaches positive infinity, y is going up, and x is going to the right, right? Because it's going this way, it's going to the right, which means it's positive. So x approaches positive infinity. All right, when y approaches negative infinity, we're going down, and x is going to the left. Sorry, I made these the exact same example, but that's fine. So in both of these cases, x approaches negative infinity. Does that make?
Can you show one where, like, if I know you just like accidentally made them the same, but like where if y goes like positive, x goes negative, so they're like not matching.
Yeah. As y goes positive, x goes negative. So, well, I guess that x goes positive. I can't even think of a graph. Let's see, maybe I can find an example. Like I said, I haven't reviewed this section very well. So I'm a little stuck here. But if you guys find an example in the course notes, I would be. So, okay, here's one. I found one. Okay, so we've got one that looks like this in the course notes. Okay, so not everything has to be squiggly, apparently. We can also deal with straight lines, right? And so here when we have y is approaching positive infinity, that would be, yeah, okay, yeah, that would be this way. X is going to the left, and therefore X is going to be negative, right? Because we're moving this way.
Okay, thank you.
Yeah, you're welcome. And then I'll quickly do the other one. As y approaches negative infinity, we're going down, and so X is going to the right. I had a brain fart there, but yeah, that would be the other way. All right, anything else from you guys? Any other questions? You guys can drop them in the chat too if you don't want to speak up.
Can we do practice like word problems from D4?
Yeah, definitely. Do you want to go off of web work or course notes?
Course notes.
Course notes, okay.
So it's gonna be like similar to like the exam.
Yeah, good thinking. Like class notes, 14 maybe. Yeah, and I can go over, oh, perfect, I made this. Let's talk about like how to approach word problems. Because last week I answered a lot of Piazza questions and so many of them were on these word problems and you guys didn't really know how to start. And I think that's the hardest part about word problems, like how do you start? And so while I'm talking about this, if any one of you wants to choose a problem from the course notes, go for it. I'll talk about this and then we'll go over like an actual problem. Okay, so word problems. The first thing I like to do is draw, right? So if they're giving us a scenario, it's really hard to visualize it if you don't draw it. So sketch it out, you know, it's not gonna hurt anybody, right? So if they tell you that, you know, for example, if they have a box and then they want to draw a line through that box. So like if they have a fence and then they want a fence through the middle, just draw that, you know, draw a box. All right, and then we want fencing. So this is fencing. We want fencing down the middle. Okay, draw a line through the middle. That's your sketch. It's that easy, okay? And if they want us to find the width and the length of the entire box, then we should label W and L respectively, right? So we don't want to label just this component, right? Because we don't have to solve for that component. So by labeling, I mean, look at the problem and see what they want us to solve for. And you should label your figure accordingly. All right, and so in this case, length would be this entire segment, and then width, obviously. And then you know, if you're cutting the box in half, and this is width, this is also going to be width, and this is also going to be width, right? So if we were just going to solve for this, that would be equal to our total width. Stuff like that you have to keep in mind. All right, next up, we would make an equation, right? So a lot of them deal with area. Well, you know, the area of a rectangle is your width times your length. And so you know that area equals WL. And so in some cases, it was really common that you would need an area formula and then another formula to solve for both width and length. All right, you guys remember solving for systems of equations, right? That was like the first or second exam, maybe, I don't know. But it was a little bit earlier in the semester and it seemed really pointless, but this is where you use it, okay? So systems of equations, you're gonna have 2 or 3 equations and you'll have 2 or 3 variables. However many equations you have equates to how many variables you'll have, all right? And so in this case, we might have 2 equations. It might ask you, or it might tell you that length is equal to twice of width. That's your second equation, right? And so now you have a system of equations and they'll give you like an area, like they'll give you a number for area. So you only have to solve for 2 variables, W and L, and you have 2 equations to solve that for. And so this would be a system of equations and you can solve using graphing, substitution, or elimination. All right, my last thing is think, okay? Guys have to think, right? We're not mindless robots, right? We're not just going through this to do the motions. We're trying to learn, right? And so when I say think, I'm just basically saying reread the question and see what is it asking for. Is it asking for area, width, length, circumference? I don't know, whatever. See what it's asking for, because especially like on the optional exam, that's going to be on web work. And you guys know web work is like super finicky. You need to read the question. So think is just, what is the question asking? Make sure you're answering that. Don't just, you're like, oh, I found that L equals 2. Well, is it asking for L, So yeah, think. Okay, so that's my approach to word problems. Let's see, we have a suggestion from Aaron. Can you do problems 4 and 10 from practice 3? Sorry, I just realized that was private. I hope it's okay that I said it out loud. Aaron, are these word problems, or do you want me to do them after a word problem?
Yeah, they're not word problems. You can just do them after.
I'll do them after. Sounds good. Thank you. Okay, so did anyone find me a word problem to do that you guys are like, I really want you to do this. It doesn't make any sense.
There's an additional practice problem that doesn't have a solution, I think.
All right.
At the page 15.
Page 15, which one?
Number 1.
Number 1. All right, cool. So this is on class notes 14 on D2L, page 15, number 1, under additional practice problems. If you guys want to pull it up. All right, so class notes 15, number 1. Oops, sorry. It's 14. Number 1 on page 15. All right, so a rectangular plot is to be fenced off and divided into 3 parts / plots on land that borders a barn. All right, thankfully for us, we have our diagram drawn out for us on there. So what they have is a barn, and then they have 3 segments. All right, cool. If you do not fence the side along the barn, all right, so I believe we're not fencing, let's use red, we're not fencing this. Find the length and width of the plot that will maximize the area if you have 200 feet of fence. Okay, so we want to find the length and the width. All right, so I'm guessing this is going to be width right here. And this is going to be length, right? There's a piece in here that does not matter at all. And that would be this piece right here, if I'm reading the question correctly. Does not matter. Don't let it confuse you, okay? We don't need to solve for it. We don't even need to worry about it. So don't think about it. It doesn't exist to us anymore, okay? And so we have width and length. And then from my example from before, we know that these little pieces will be equivalent to our width. All right, so we have 4 blue lines and we have 1 green line. So we know that we have 4W and 1L. Let me make sure I'm doing this right. Okay, find the length and the width that will maximize the area. All right, so it's talking about area. This is really common for this unit. We're probably going to use our area formula. All right, and it gives us a number. We have 200 feet of fence. So 200 feet of fence. Well, these 2 numbers, when you add them together, will give us the amount of fence total that we can use, right? And we probably want to use the entirety of the 200 feet because we want to maximize our area, right? You're going to use as much fence as you have to get your largest area. So from this information, we can make our second equation. This is our first equation, right? We have 4W plus 1L equals 200. All right, and this is our second equation. System of equations, right? So we drew, we labeled, we made our equations. Now we're going to solve. All right, and so I'm going to rewrite this one as 4W plus L equals 200. All right, so we can use a couple different methods here, but I am going to use substitution because I have an L here alone. we're gonna do L equals 200 minus 4W. All right, and so we'll have area equals, so I'm gonna plug this L back into the area equation. All right, so this is where I'm getting this. Area equals W times 200 minus 4W. So essentially we've combined these equations. Why have we done that? So that we can get our area formula in terms of one equation, or in terms of one variable. Because before we had W and L, now we just have W. We don't have to worry about the L until later on. Okay, and so I'm going to distribute this W. Area equals 200W minus 4W squared. All right, so this is kind of in terms of like Y and X, if you think of A as Y and W as X. And so we want to find the maximum area. What is the largest area that can be enclosed? Okay, so maximums. What should we be thinking about with maximums? Shout it out.
The vertex formula.
Vertex, great. How do we find vertex? Well, we can start with H equals negative B over 2A. If you do not know this formula, write it on your formula sheet, okay? Because I'm like 99% sure you're going to use it at least once on the exam, if not more than once. All right, so that's how you're going to find vertex. And then if you're not sure to find K, you just plug in that H back in for X, and then K would be your Y value, or in this case, A. Okay, but we're going to hold off on that. We'll use it later. Okay, let's find our X value of our vertex, which is our H. So negative B over 2A. Well, if we see here, this is our A value, and this is our B value. Okay, and make sure that you keep that negative sign with the 4W squared. All right, so B is 200. So we have negative 200. And A is negative 4. So 2 times negative 4. That's going to give us 200 over 8, which
25.
I'm not a whiz at math, but that's 25. All right, so 25 is our H value. 25 is also our W, right? So that's going to be our width that will give us the maximum area. Okay, so make sure you understand that statement. Width that gives max area. All right, so we want to know what our vertex stands for. That's what it stands for. Okay, so what is the question asking for? What is the largest area that can be enclosed? Do we need to know the length?
No.
No, exactly. That's important to know, because if we're having timing issues, we don't want to spend time figuring out the length, right? We have the width, that's all we need. Now we have to solve for K, right? K is going to be our Y, which is going to be our A, our maximum area. All right, so let's plug in our 25 back in for W and solve for A. A equals 200 times 25 minus 4 times 25 squared. That's going to give us our maximum area. So 25 squared times 4 is going to be 2,500, and 200 times 25 is 5,000. So 5,000 minus 2,500 is 2,500. And that is our answer. I should say 2,500 feet squared. Those are the units. You should probably have units, but yeah, you guys get the idea. Any questions about how I did that? Or any questions about vertex in general, or word problems?
If we were to find the length, I'm like, if the question asks hypothetically to find the length, then how would we find the length?
Yeah, sure. So we have W equals 25. We didn't need to find length, but you probably will in some cases. So we're just going to take that W equals 25 and plug it back into the equation that has length in it, okay? And there are actually two different equations you can use, because we know that 2,500 equals our A, which is also equivalent to WL. we also know that L equals 200 minus 4W. Okay, so you can plug back in your W for either of these, right? So for area, if we did 2,500 equals 25 times L, 2,500 divided by 25 is 100, so L equals 100. On the other hand, you could do L equals 200 minus 4 times 25. 4 times 25 is 100. 200 minus 100 is 100 again. You can use either of these options. Personally, I would use the second one just because it already has L solved for, but yeah, literally either works. Okay, let's go over number 2 real quick by request, and then we'll move on to some other problems. Okay, so same page, number 2. You have 300 feet of fencing to enclose 4 garden plots as shown below. All right, so they have our garden plots already drawn for us. Sorry, that's like a terrible square. Anyways, that's our picture. Find the length and width of the outer dimensions that will maximize the area. What is the largest area that can be enclosed? Okay, so very similar. Sorry, this is like bothering me. I think I need to redraw this. All right, that's a little better. Okay, so we have 4 garden plots. We have 300 feet of fencing. And we want to find the maximum area. Okay, so again, let's figure out what we're solving for. We're finding the width and length of the entire plot, right? Not just one of the small ones. So we'll make this our width, this our length. Side note, you could actually switch these two and you'd still get the same answer. But usually width is the shorter one. Okay, and so we have 3W, right? And we also have 3L. Is everyone okay with how I determine how many W's and L's there are?
So even with it just being the outer dimensions, you still include like the ones that cross in the middle.
Right, because we want to enclose all of these garden plots. Right, so we need to fence every single little block, but we just want to find the overall maximum area. So even though we're only solving for that overall W and L and overall area, we still need a lot for that fencing for every single plot, which is why we're setting.
Okay, thank you.
Yeah, you're welcome, which is why we're setting 3W, 3L equal to all of our fencing. Okay, cool, so we got that. I'm just gonna like run through the rest. We know that area equals WL. And so again, you would just solve. I'm going to use substitution. So we'll have, say, 3L, or let's do the other way, get some practice. Say 3W equals 300 minus 3L. So in this case, you can solve for either W or L. It doesn't matter, right? You're just going to solve for one of them. And then divide everything by 3. So we'll have W equals 100 minus 1L. Plug that back into our area equation. So the area equals 100 minus 1L times L. Distribute the L, so we'll have 100L minus L squared equals area. Find the vertex, right? So H equals negative B over 2A, which equals negative 100 over negative 2, because in this case, RA is 1. Or RA is negative 1, sorry. And so we will have 50 equals our L, right? So our L is equivalent to our H. If you wanted to put in an X for your L, that's fine too. You can always say that, W is X and L is Y. It doesn't really matter what your variables are. Okay, so 50 is L. We want to find the largest area, so I'm just gonna plug that back into this equation. So we'll have, oh, sorry, not this equation. That'll solve for width. If you wanna solve for width, then you use that one. But we're not solving for width, right? We're solving for area. So I'm gonna plug it back into this equation. Area equals 100 times 50 minus 50 squared. All right, and so we'll have 5,000 minus, I think 2,500 again. All right, so we get 2,500 again. And that's our final answer. I think that's feet squared. All right, any questions about that? Setup was a little different from number one, but in the end, it's very similar. Okay, looks like we're all good.
Can we go over division problems?
Division, yeah, sure. I'm gonna go over Aaron's problems first, and then we'll do some division. Let me make a note. Okay. Problems 4 and 10 from practice exam 3. All right, Aaron, there's 2 practice exams. There's Brian Chadwick's, and then there's, I think, Sharon's. I think Sharon, they're gonna go over 6.
Okay, that's the one that it was.
Okay, I'll hold off on that because I think she's gonna go over at 6. And if for some reason she doesn't, shoot me an email and I'll do it for you. But I think she'll do that one. Unless it's from Brian's. Maybe I heard you wrong.
Yeah, I think it was Alan's.
Okay, yeah. So then she'll go over it like in an hour.
Okay.
Okay, but let me do a division while we're here. Fadumo, do you have a specific problem you want me to do?
You know the practice problems that we have, like objectives. It was from D1. And if you press on that, it'll lead you to me and Kieran were doing them together yesterday, and we had a lot of problems with the division.
Okay. All right, here's like the first one I saw. Okay, so this is on D1 practice problems, and it's problem number 2. This is on D2L, but I'll rewrite it for you guys. It's 2A. So, division, fun stuff. You guys all love this, I know. Okay, so we're gonna set it up just how we would set up division in elementary school, right? So we're gonna have our little bracket thingy, whatever it's called. We're gonna put our numerator inside the bracket. So we'll have x cubed minus x squared minus 2x plus 6, all divided by x minus 2. Okay, so first off, we're going to look at the outermost one, which is our x, and we're going to see what can we multiply by that x to get x cubed, right? So x times x squared would be x cubed, right? So we can write an x squared up here. So we're basically just kind of like pulling out this x minus 2 from our big expression. And so we know that when we divided x cubed by x, we would get x squared, right? And so vice versa, when we multiply x by x squared, we'll get x cubed. Okay, so now we're going to multiply what we put up at the top and what's on the outside and subtract it from our inside. Okay, so x squared times x, we're going to get x cubed, and we're going to subtract that. Okay, so we're just like, the reason we're subtracting is we're kind of like, okay, we already took care of it. We can move on from it. Let's get it out of our expression. Right? Okay, so we don't only have x though, we also have -2. So we're gonna have to multiply that x squared by -2 to just kind of like get rid of it. And you know what I'm saying? Like we're multiplying everything by that x squared. So we also have to multiply the -2. All right, so x squared times -2, it's gonna be -2 x squared. Don't forget we are subtracting it. So a negative is a positive, right? Does that make sense? Hopefully you guys all kind of have the hang of it, but yeah. So the point of making it negative is that these first two will cancel out. So if you don't get a 0, you probably did something wrong. Okay. Not to be blunt, but yeah, you should go back and check your work. Okay, so x cubed minus x cubed, 0. Negative x squared plus 2x squared will be x squared. All right, and so from x squared, we're going to move on. We're going to do the same process all over again. We're going to bring down whatever we have left.
What happened with the positive 2 with the x squared?
I added that to our negative x squared. You're talking about this one, right?
Yeah, like why didn't that go down also?
Yeah. So we have like an invisible.
Oh, wait. Yeah. I see it now.
Okay, cool. All right, so perfect. Yeah, so we'll move on from here. We're going to take out an x from our x squared down here. And so x squared divided by x would be x. You could also say x times x is x squared, right? We're going to minus an x squared. And then we're going to multiply it by our negative 2. So x times negative 2 is negative 2x. And that's all we have left. Oh, but we have to make it negative because we're subtracting. So we'll have negative is a positive. So we'll have 0, 0, plus 6. We don't have anything left here to bring down. And so we're basically done for now. Our remainder is 6. And then we have a, I don't know if it's called quotient or divisor or, whatever. I think it's quotient. But yeah, we have a result of x squared plus x. So far, we have what they gave us. X cubed minus x squared minus 2x plus 6 times x minus 2, or sorry, that equals x minus 2. And then that equals x squared plus x. And with a remainder, I think she went over this, but you would just have your remainder divided by what you divided with. So that's this. So it'd be 6 divided by x minus 2. But I think she just leaves like a blank spot for your remainder. All right, so we're not quite done though, right? Because there's one thing left in here that we can still simplify further. Now we read this right here because both of those expressions have an x in them that we can factor out. And so our final form would probably be x minus 2. Factor out an x from that x squared plus x. So we'd get x plus 1. And then our remainder divided by what we divided with. Does that make sense?
I have a question.
Yeah.
So then like on the exam, are we just gonna be expected to write it like this, or would there be spots where it's like the quotient and then the remainder and then?
I'm almost certain she would give you spots and like the remainder, but you should definitely conceptually understand that when you're dividing like the top by something, that means that your result will be that top equal to everything you divided it with.
Okay, thank you.
Mm-hmm. It's kind of like, you can think of it as like 6 divided by 3, and they're asking you what that would equal. You know that 6 would equal 3 times 2. So it's kind of like you're multiplying this bottom by something, and then whatever you multiplied it by, those two combined will equal your original, if that makes sense at all. Okay, anything else you guys want to go over? I hope you're all planning on going to the presentation at 6.
Oh, I'm sorry. You can go ahead.
Yeah, go ahead.
Okay, so I have a question. For the factoring part out, is that just to check your work, or is that like an actual required part of the problem?
For the factoring part, like this part down here, or?
Like the whole thing, because when we were going over it in class, honestly, I don't remember. I'm gonna look back at my notes, but like I don't remember doing the factoring part in class, if that makes sense.
So which?
Because when we were doing the division, huh?
Oh, go ahead. Yeah, you were saying.
Because when we were doing the division, she just left it at the actual like division solved out part, and like the remainder, and then like the x squared plus x, but I never remember about the factoring part.
Gotcha.
So is that like to check your work, or is it just like required to know for the exam too?
I was rewriting it. Like I said, conceptually, you definitely want to like understand this because I have no guarantees on how she's gonna have you write your answers. This is just another way of writing your answer, right? So
Oh, okay.
yeah, but in this case, this part, you would definitely need to factor that, like reduce it further. Otherwise, I'm sure we would dock points for that. So
Okay.
you would want to rewrite it or at least just realize that this is not your final answer. You can still factor out more from it.
Okay, makes sense because I was really confused on that part.
Yeah, I gotcha.
Would you mind going over the concept of multiplicity?
So do you have like a practice problem? So I'm not really sure what exactly concept that would be, but
Oh, okay. I'll find that hopefully.
okay. While we do that, I wanted to go over discriminant because on the lab, everyone I invited to this meeting is in one of my recitations. So overall, you guys seem to kind of struggle with that one. So I just want to go over it real quick. So discriminant. What is our discriminant? We have a formula for it, right? Anyone want to rattle it off?
I know we had like a 4 minus something.
Yeah.
C.
B squared minus 4AC.
Pretty close. B squared minus 4AC. This is the inside of our quadratic equation. So if you don't have this memorized, which, I don't expect you to, formula sheet, right? Write it down on your formula sheet. Okay. Also, another thing you should write down is how can we tell how many solutions there are to a formula, right? So we have a formula, a squared plus ax squared plus bx plus c. And that's where these numbers are coming from. If our discriminant is equal to 0, we have one real solution. If it's greater than 0, we have 2 solutions. If it's less than 0, we have 0. Okay, I think that's right. Someone fact check me on that. I don't know. I'm a little tired. But yeah, basically, if it's greater, equal, less than 0, that's how we know how many solutions there are to this specific equation. So that's what you would use your discriminant for. And then you would solve to find like an actual number. So the output of your discriminant would be a number, right? You're not gonna like get another equation out of it, which I kind of saw, which was a little weird. You're gonna get a number. And so you want to see that number negative, positive, or 0. And that tells you how many solutions you have. Okay, so that's our discriminant. Back to, I forgot who talked last, but someone had a question.
Oh, so I kind of found the question about multiplicity. I don't know, am I saying it right? It's on lesson 16, the warm-up group question.
Lesson 16. All right, let's check it out.
It says, hint, think about multiplicity.
Okay, so are you on like the class notes for 16?
It's on page 1.
Okay. Gotcha. Multiplicity. Multiplicity.
So what I'm confused is that how do we know that the graph crosses or touches the points with the roots according, and what does it have to do with the even and the odd number? Like what's the connection of how we know it's connected, like with even and odd number?
Gotcha. Okay, so let's see, class note 16, page 1. So yeah, so in terms of multiplicity, whatever, you guys know, I'm not certain what they mean by that just because it's like kind of vague. But basically what they found here is if you see at the beginning, crosses the x-axis in 2 and -5. From those, you know that, roots, right? Because crosses the x-axis, that means a lot of things. That is the x-intercept. That is also your roots, also called zeros. Zeros. I don't know. Anyways, zeros, right? So from all those words, these all mean the same thing, okay? And from that, you know that wherever it crosses, that is like an x equals, that's your root, right? So you have x equals 2 and x equals -5. And then it also tells you that it touches the x-axis at 0. That, again, is an x-intercept. That's a root. That's a 0, blah, 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 blah. So you know that another one is x equals 0. Okay, so, oh, okay. And so she's telling you that you're going to have 2 x equals 0s, which means that has a multiplicity of 2, right? And so she's saying that x minus 2 is odd, x plus 5 is odd, and x and x are even. That one I'm a little lost on. So I actually don't go to her.
It's probably, I think it's because, like, you know how if the graph touches, it should be even number, and if crosses the graph, it should be odd number, maybe because of it.
That might be it. Yeah. Like I said, I haven't really reviewed it, but that would make sense, because if it's touching, then you would have even. But basically, you know that if it's crossing, it can only have like one 0 there, right? And so I think that's why she's put it as odd. And this might be a good question for her, or I can look more into it and shoot you an email. But I think what she said is that, yeah, you have a few different options, right? So you know that these are going to be even and these two are going to be odd. And so in terms of odd numbers, if everything has to equal 6, you can make your odd either 1 or 3. Probably don't want to make it 5 because you won't have enough left for the other expressions. So you could either have like a 3 here and 1 here. So you'd have 4 and then 1, 1. Or you could have a 3 here, a 1 here, another 1, 1. Or you could have 1, 1, 2, 2. I think that's what she was trying to say, that if it's touching, it's going to be even, like you said, and therefore you should just make sure that the exponents all add up to 6 and are respectively even or odd.
So with respect to the description in the first bullet, so would our graph look like the downward facing downward, or would it look the upward, like facing upward? Like, do you get it what I mean?
Yeah. So basically when it's telling you it falls left as x goes to -infinity, that will just tell you that as we're going leftwards, the graph is also going left. So you know that the graph is going like that way, right? And then as x goes to +infinity, it falls right. We know that it's falling right that way, if that's what you were asking.
Yeah, I was just confused, like how do we know that it's going this way or some way, that way? Like, yeah, okay, but I get it now. Thank you.
All right, cool. That one I'm like not as familiar with, so sorry. I wish I could be a little bit more helpful, but hopefully if you guys like can rewatch her lecture, she might have explained it a little bit better.
I have a question.
Yeah, go for it.
When a question says like put something in terms of like x or any other variable, what does that mean? What's like in terms of?
Yeah. In terms of would be like if you had y equals x z w, we want to somehow get this into y equals x something, right? So it can be like x times x times x. Basically, you would use other expressions like z equals x squared and w equals x minus 2 in terms of x to get this overall expression y in terms of x. So basically when we want an equation, say our equation is y, when we want that in terms of x, that means we want x to be the only variable in the equation. Oops, I can't spell. Only variable. Does that make sense?
Yeah, thank you. So like if the equation, like the example when you have it was like y equals x, z, blah, 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 you want to figure out how to get rid of the z and w and just have
Exactly.
x with other expressions? Okay.
Yep. And so you would just substitute that in for z and w. So you get x times x squared times x minus 2. And then it would be in terms of x.
Okay, thank you.
All right, so we have a few more minutes before her review starts. I wanted to go over factoring methods also. So there are 3 factoring methods. Let me try to remember what they are. Okay, yeah, so we have grouping. There might be more than 3, but I could just think of 3 before the start. But we've got the grouping method. We've got like what I call the normal method. And then we've also got the quadratic equation. And something I struggled with when I was in algebra with factoring is, when you know which one to use, right? And so grouping, basically you're going to use when you have 4 expressions, but the middle 2 are going to be like in the same terms, like they will be like terms. So it'd be like a plus b1x plus b2x plus c. Sorry, it'd be ax squared, right? And so the point of grouping is that you can group the first 2, group the second 2, and then solve from there. So it's not always going to be given to you as 4 expressions, but you would use grouping when you have like a normal equation, and then you can split the b value and then group from there. So yeah, grouping is one. A normal is the other one where you just have like a normal ax squared plus bx plus c. Hopefully you guys have practiced this enough so that you know like right away when it's going to be an easy equation to factor and you don't really have to think about it. You can just do it, Quadratic equation, this one is nice because you can use this for anything, right? So even if you have like a normal easy equation, you can still use the quadratic equation. It's going to work for any number. The point of using it is so that you can use it on the hard numbers because it's like time consuming, it's hard, you make a lot of little mistakes. But if you're ever like, I don't know what method to use, quadratic equation will work for anything. But then again, the exam is timed, so keep that in mind. You want to know how to use all of these methods. But yeah, just so you know, quadratic equation works for anything. Any questions about how to factor? Okay. Yeah, let's do a division problem. Okay, so in the chat we have 12x cubed plus 16x squared minus 9 over 4x plus 4. Alrighty, so we're going to divide this out. And if you guys want to go to the review session, feel free to dip at any time. I won't take it personal. But yeah, let's get through this problem. Okay, so first off, we're going to approach it just like we did the other one. So we're going to figure out what can we multiply by 4x to get 12x cubed. Well, in this case, we can multiply 4 by 3 to get 12, right? 3. And then attached to that, we should have an x squared because x times x squared will give us x cubed. All right, so we know that 3x squared times 4x will give us 12x cubed. All right, so we're going to subtract 12x cubed. And actually, let's go about this a different way. We won't subtract yet. I find it's easier if you just like put it out and then subtract everything at once. Depends on what method you like. let's try it this way. Okay. Yeah. Then we have 3x squared. We're going to multiply that by 4 because we have to multiply everything by this little thing over here. 3x.
Priya, sorry to cut you off.
Yeah.
For the long division with like x cubed plus x squared, don't you have to add like the 0x?
Ah, yeah, you're right. Okay,
But
so
I also noticed in the solutions, the person who did it did not do that. Like they just went 3, 2, and like constant. If you know what I'm saying.
yeah, so it depends on the problem. You don't actually always end up using this 0x. And I ended up like emailing back and forth with one student about this. For this specific course, you should always include that 0x, that placeholder, because it's on our rubric. That's how we grade you, at least for one of the labs. So as an instructor, like as a grader, I would say include that placeholder. But as like just a person who does math, obviously I didn't even think to include it yet. You find that as you work through the problem and you realize, oh, like your stuff isn't matching up, like you end up with an X under your 9. Well, that doesn't make sense because they're not like terms. In that case, then I would be like, oh, I should add a placeholder. But sometimes you don't even end up with like mismatched terms. It really just depends on the problem. And so in that case, you don't actually end up using the placeholder. But for this class, you should always put in that placeholder. Right, so yeah, thank you for pointing that out. On the exam, on your assignments, use the placeholder. When you're just doing math for fun,
Okay.
on a Saturday afternoon, make sure you just like do whatever you want. Got it?
Got it. Thanks.
Okay, cool. So we're going to multiply 3x squared by 4. And so we'll get 12x squared, right? Because 3 times 4 is 12. All right, so both of these ended up being positive. So we're just going to subtract them out. So I'm going to put negatives. And we'll end up with 0 plus 4x squared. Then we're going to bring down what we have. So we're going to bring down the placeholder and bring down our constant. All right, so next up, we're going to work off this line. So we have 4x squared. What can we multiply by 4x to get 4x squared? We can multiply by an x. Let's write an x up here. It'll be a positive x. So x times 4x will be 4x squared. Yep, okay, so review is starting now for Miss Allen if you guys want to jump out or you can hang around. No hard feelings. Okay, but yeah, that's starting now. All right, so 4x squared and then x times 4 will be 4x. So we'll add that under our placeholder. So if I were just doing this for fun, at this point, I'd be like, oh, I should add a placeholder. You guys should just add it at the beginning. Okay, but this is where you use your placeholder. And then we want to subtract everything. So we're going to change everything to negative. So we'll have 4x squared minus 4x squared will be 0. And then 0x minus 4x will be negative 4x. And then bring down that negative 9. We have minus 9. Oops, my bad. Hold on. We're going to have, no, just kidding. I'm good. Yeah, no, I already did that. Okay, yeah, so we have negative 4x minus 9. All right, well, what can we multiply by 4x to get negative 4x? A negative 1, right? We just want to make it negative. So we'll have negative 1 times 4x will give us negative 4x. And then negative 1 times 4 will give us negative 4. All right, so we're subtracting, so we're going to switch the signs on everything. So I'll have positive 4x and positive 4. So we'll have 0 minus 5. And this negative 5 will be our remainder. And then this up here is our answer. Any questions on that? We can rewrite it as 4x plus 4, 3x squared plus x minus 1. And then our remainder is negative 5. But if you wanted to rewrite that, you could do it as negative 5 over 4x plus 4. All right, any other questions you guys want to go over?
Do you think we should rewrite it like that on the exam too? Like in the factored form? So like we'll have our quotient and remainder, and then we should write it like that too.
You should do exactly what it asks for and nothing more, because a thing is like
Okay.
you guys manage to get everything right up here and then you write it wrong down here, we might ding you points.
Right.
It doesn't ask you to do this,
Right.
don't bother.
Okay.
But I think at least on the lab, she just had like quotient and then like remainder. And then just have you like write both of those. So that would go there and then that would go there. And then just like cut it off. Okay, and then sorry, I didn't let you guys know I have been recording. So I'm gonna post this recording, or at least I'm gonna try because I got a lot of emails about that. But yeah, let me know if you guys are like uncomfortable with that and I can like censor it or something. Okay, I thought I heard a question.
I'm good. Whatever you do.
Okay.
I just have one more question.
Okay, Kara, go ahead.
Could you do quickly like transformations? I didn't get that like when we learned it really the first time. Like with the HSRV.
Okay,
Or do you know if that'll be on the exam at all?
yeah, is it objective D6 or D5?
Let me check real quick.
I think it was D6, but
I think
I'm
so.
not sure. I would check again.
Because D5 is just like about leading coefficients, you know, this that simple. I mean, not simple, but just that type of problems, while D6 was more of like transformations.
Gotcha. Okay. Transformations for square roots, right? Okay. Yeah. I'm gonna assume yes. Okay. Yeah, so transformations. We went over like a lot of them in the last unit, but basically what I'd recommend is to write down like all these possible things on your cheat sheet, especially since this was the last like thing she just went over. I don't know what day you guys did this on, but it couldn't have been long ago. And so definitely like just write down what happens when you make x negative, when you make y negative, when you add inside the square root, when you subtract, when you add outside the square root, when you subtract, when you multiply. Like there are so many different things. You guys, if you're not sure, just write it down. Another tip I have is you guys all hopefully have these really expensive calculators that seem like they're completely useless, but they're probably smarter than you. So you should use them, you know, they're your best friend. So you can hit y equals and graph your equation and see what's happening to it, right? So if they want you to reflect it over an axis, you can kind of play around with your calculator and graph stuff and see what makes it reflect. Ideally, you don't do this, you know, on the day of the exam, but if you have to, do what you got to do, right? Use your graphing calculator and use your cheat sheet because it's open notes. So yeah, about transformations. I'm looking at page 3 on her completed class notes number 16. But basically she has like a general form, bx minus c plus d. I don't know why she has a minus, but yeah, anyways. So when you are when you're looking at like shifts, maybe we'll start with that. You have two. You have vertical and horizontal. Right, vertical referring to your y-axis, horizontal is referring to your x-axis, and so vertical you can go up or down. When you go up, it's going to be positive. When you go down, it's going to be negative. That's pretty self-explanatory. Horizontal, you have right and left. When you go right, it's going to be negative. When you go left, it's going to be positive. This one's a little bit more confusing, in my opinion. I don't think it's that intuitive, but yeah, it's just something to memorize. It's kind of like the opposite of what you think it'd be. Right is always going to be negative, left is going to be positive. All right, what do these positives and negatives mean? Well, that just means, are we adding or subtracting our shifts, and where are we adding and subtracting them, right? So when we're adding or subtracting something to the entire equation, and so in this case, this would be our plus d. This is going to give us our vertical shift, right? And so when it's plus d, it's going to be up. When it's negative d, it's going to be down. And the difference is when you have y equals, you're adding or subtracting to the entire y expression. With this minus c, you kind of ignore the minus for now. But yeah, with our c, it's inside of the square root. And so how I like to think of it is as when you're adjusting inside the square root, that's like really close to the x, which means we're going to be adjusting our horizontal, or like our x shifting, if that makes sense. Or you can just memorize it. But if you want to add some conceptual stuff into there, that's my attempt. Okay. So yeah, important to know that right is negative, left is positive. Or you can know this like negative c. That's why she's a negative instead of a positive. It's because it's like the opposite of what you'd expect. Yeah. Okay, so those are our shifts: vertical, horizontal, reverse to C and D. Our shrinks and stretches are going to be our A and B values. And again, you can kind of think of it as like applying it to the entire function as opposed to like applying it to just like the insides where the x is under the square root, right? So B is going to refer to our horizontal, which is going to be our x, and we're going to have a stretch. Hold on, color code it. Stretch / shrink. So that's one. And then our other one would be vertical, which is going to be our A, because that's like applying to the whole function. So that's going to be our Y. And then let's see, this, like, I literally have never memorized this. I don't think ever. Maybe like once for a test. So if I were you guys, I would write at least the stretching and shrinking down on your cheat sheet, or be prepared to like figure it out on your calculator, because it confuses me. But if you can memorize it, good for you. I'm very proud of you. But yeah, it says if A is less than 0, then you're flipping over the x-axis. Well, stretching and shrinking, whatever, like fractions and all that, you guys can figure that out. But important to note is your A and B values, are they negative or positive, right? And so when our vertical is negative, vertical being A, we're flipping it over the x-axis. So when like that corresponding y, that vertical, that A, when that is negative, we're flipping it. All right, over the x-axis. That's important. What does the x-axis flip look like? Our original may look like this. When we flip it over the x-axis, it's going to flip that way. And so it's going to look like this. Okay. Horizontal. When B is negative, when B is less than 0, all right, you're going to have a flip again, but it's going to be over the y-axis. All right, so a flip over the y-axis. Let me reach out. Okay. Like that. We're going to flip it over the y-axis, and we're going to get something that looks a little bit like that. All right, so it's going to be like opposites. If you're like unsure about any of this, you should definitely just write this stuff down on your cheat sheet. You should also know how to use it though. So don't just write it down and forget about it. Make sure you know how to use it quite fast. So like practice with it. But yeah, that's kind of what I would write on my cheat sheet. Maybe neaten it up a little, you know. But yeah, does that make sense, guys? Does that help?
Yes.
Yes. Okay, I got a yes. Very nice. Anything else you guys want to go over before I send you off?
Is that all you wanted to go over? Or do you have?
I mean, I'm here for you guys. So I just had like a few concepts I wanted to touch on, but I think I got all of mine. So yeah, if you don't have anything else, you guys should definitely head off to that other review because I'm sure you love to do 3 hours of math in a row. I'm sure that's like your biggest desire right now. But yeah, if you guys don't have anything else, anything at all, yeah, thank you. Yeah, you're welcome, guys. I'm gonna try to figure out how to post this on YouTube. So if you want to listen to an hour of me talking all over again, feel free. But yeah, I'll try my best to send it out.
Thank you.
Yeah, you're welcome. Bye, Fadumo.
Bye.